All right, this is the life cycle of a star graphic organizer. Here's the front side that's actually showing you a diagram of the life cycle of a star. It starts off as a nebula, all stars do. Then it moves on to a protostar, then it becomes a main sequence star, and then depending on the mass of the star, you'll either take the average star path, such as our sun, or if you're about 40 times the mass of our sun, you'll take the massive star path. So from here, you either become a red giant or a super red giant. If we're an average sized star like our sun, after the red giant, we'll become a planetary nebula. And then as we start to die, our sun, it will become a white dwarf and then eventually a black dwarf. If it is 40 times the mass of the sun after a supergiant, it'll become a supernova, and then it could become a neutron star, or if it's massive enough, a black hole. So let's fill out the backside together. The first step, as the picture shows again, is a nebula. So a nebula is large amounts of gas and dust spread out in an immense volume. And then the second step is a nebula to a protostar. A protostar is a star without light, so nuclear fusion has yet to begin in that star. That's a typo. Nebula. Okay, so protostar is next. The third step that all stars take, so they go from nebula to protostar, the picture shows that it goes to a main sequence star, which is the current stage our sun is at. So a main sequence star is a star that begins to emit light. That means nuclear fusion has begun. Okay, so next you have two different paths, the average star path and then the massive star path. We're going to start with the average star path, which again, this is the path our sun will take. So after the main sequence, our average star will become a red giant. So 5A path will become a red giant. A red giant star begins to lose fuel, the core becomes unstable, contracts while the outer expands. After the red giant comes our planetary nebula. This is created when a red giant runs out of fuel and the outer gas layers is blown away. So planetary nebula. After the planetary nebula is the white dwarf. This is where the remaining core of the planetary nebula. So all the gas is blown away and you're just left with the core. So that next step is the white dwarf. A white dwarf, since it is just the core and it's no longer emitting light, or it's ran out of fuel, I should say, it's now very, very dim. So it still has just a little bit of light. And then the last step is a black dwarf, and this is where a white dwarf has radiated all its energy away. So it's the final stage of the death of a star. Next path is going to be if it's a massive star, and it's definitely not our sun. So after it becomes nebula, protostar, main sequence, then it goes this way and it becomes a red supergiant. Now it's just habit that I say red. You can get a blue supergiant, which means it's a really hot star, but that's okay. So next step is a supergiant. It forms when a massive star begins to run out of fuel, just like a regular giant. After a supergiant, it becomes a supernova. So here's our picture again. Supergiant becomes a supernova. A supernova is the death of a supergiant via an explosion. So basically, nuclear fusion stops the core and or nuclear fusion stops, period. And then because there is no more nuclear fusion, the core begins to collapse upon itself. And then now there's like another split where you could have, after a supernova, you can have a neutron star, or if it's 40 times the mass of the sun, that's what this M times 40 is, then it becomes a black hole. So it has to be a very, very large star for a black hole to occur. So neutron star is next after the supernova. The remaining piece of the star's core that's left over is what it is. And it can even, it's also sometimes called a pulsar, and it's kind of like your blinking or your twinkling stars in the sky. You see it, basically, your star is dying. And then the last stage, if it does not become a neutron star and it's 40 times the mass of our sun, it will become a black hole. Basically, the gravitational force is so strong, the core collapses upon itself, creating the black hole. And we know there are black holes because if you watch a chart a star and then all of a sudden it disappears, we theorize that there's a black hole right next to it because the light can't escape a black hole. So therefore, we use theory because we can't actually see a black hole. I'll give you a few seconds to write this definition. You're definitely going to want this piece of paper for your Flipgrid that you're going to have to do here in just a minute. So make sure you can read it and then glue it into your comp book so that you don't lose this.